The generator was running at full load. Nobody was checking fuel gauge because nobody thought they needed to. Then the engine note changed. It's tumbled. Then a bigger one. Within seconds, the whole site lost power. I was there. And what happens within few seconds and minutes after is what most people don't expect. If you run a generator at full load, you need to know what happens when fuel runs out, because it is more damaging than most technicians realize. What actually happens the moment fuel runs out? Let's start with what is physically happening inside the engine. When fuel supply drops, the engine does not simply switch off cleanly. Combustion becomes inconsistent, cylinder by cylinder, before it fully stops. Some cylinders are still firing, others are starving. It means the engine is producing uneven power across its cylinders for a few crucial seconds. This uneven power output is where the real damage risk begins. The governor is still trying to maintain speed, calling for more fuel that simply is not there. Frequency and voltage become unstable together. Not just frequency alone, because the AVR is also reacting to the same falling engine speed. If the generator is carrying crucial load at that moment, motors and sensitive equipment downstream experience that instability directly. Voltage sag, frequency dips, sometimes fall under voltage or under frequency trip depending on your protection settings. Then the engine stops, not gracefully, it stops the way a car stops when it runs out of fuel on a highway. However, many pistons happen to be mid-stroke at that moment. The hidden damage most people miss. Here is what most technicians do not think about afterward. Everyone focuses on refueling and restarting. Almost nobody checks for the damage that already happened. First, air in the fuel system. Once fuel runs out, air enters the fuel lines and injection system. This is not optional. It always happens. If you simply refuel and try to restart without bleeding the system properly, you get rough running, failed starts, or in worst cases, injector damage from air pockets, disrupting proper lubrication and fuel delivery inside the injection pump. Second, injector pump wear. Diesel fuel itself lubricates the injection pump internally. Running dry, even briefly, removes that lubrication at the exact moment internal components are still moving under load. This is one of the most expensive and most overlooked consequences of a fuel run-out event. Third, electronic load damage downstream. If your generator was carrying sensitive load, UPS systems, control panels, variable speed drives, the voltage and frequency instability in those final seconds before shutdown can stress or damage equipment that was never designed to tolerate that kind of fluctuation. Fourth, and this one surprises people, repeated fuel run-out events accelerate wear on the entire fuel system faster than normal operating hours would suggest. A generator that has run out of fuel 3 times in its life often shows fuel system wear equivalent to hundreds of additional running hours. What to do and how to prevent it. If this happens on your site, here is the correct recovery sequence, not the rushed one. Do not simply refuel and hit start. Read the fuel system properly first, following the manufacturer's bleed sequence. This removes trapped air before you attempt a restart. Skipping this step is exactly how people end up with a no-start situation that looks like a bigger fault than it actually is. Inspect for any abnormal noise on restart. This can indicate injector or pump damage from the dry run event, not just normal air in the system. Check downstream equipment that was connected during the event, especially anything sensitive. For any tripped protection or visible fault, do not assume everything downstream survived cleanly just because the generator restarted fine. For prevention, the fix is almost always simpler than people expect. Low fuel alarms are frequently ignored or set too close to actual empty. Set your low fuel alarm with a real margin, enough time to actually respond before the tank runs dry, not just a warning light nobody notices until it is too late. If your site is automatic fuel monitoring or remote tank level sensors, use them. This is one of the cheapest prevention measures available for one of the more expensive and disruptive faults you can have on site. Here is the big picture. Generator running out of fuel under load is never just an inconvenience. It is a mechanical stress event, an electrical stress event, and downstream equipment risk event, all happening within the same few seconds. Treat it that way every time it happens, not this simple refuel and restart. Before you go, drop one thing in the comments. What happens when a generator runs out of fuel under load? What happens thereafter? I read everyone. Next week, I'm covering ATS, closed transition versus open transition, and the mistakes that happen on site that hinder the transfer. Subscribe so you don't miss it.